Hey everyone, I want to thank you for tuning in to one of ePartrade's Race Industry Now Tech webinars. If you're a part of the racing industry or you're just passionate about racing tech, don't forget to like this video and subscribe to our channel so you never miss a new episode. Welcome once again. My name is your host. My name is Brad Gillie, your host for today. We have Judy Keene and Andrea Brake here with us, and a great webinar today, which we're looking forward to. And we definitely look forward to learning a lot, educating, and helping you out as well. But we do want to thank our sponsors, Performance Plus Global Logistics, Ferreira Racing Components, ARP, Fifth Third Bank, Crower Cams, C-Tech Manufacturing, and Peak. And this is going to be a lot of fun talking about wet sump systems with Canton Racing Products. And Judy, I'll first turn it over to you before we get started.
Thank you, Brad. And thank you, everyone, for joining. Hard to believe we're on episode 548, and we're delighted to have on such a iconic hardcore racing performance company on today. So we're delighted about that. And if you're new to us, this racing series, we've also created a B2B performance racing platform. So please sign in. You're going to see companies like today, Canton and other brands exhibiting. So enjoy the platform. Andrea?
Thanks, Judy. Yeah, I've had the pleasure of knowing Canton Racing Products and working with them a long time as they were my customer at PRI, and we're just really happy to have them on the platform. They're a great addition to the platform, and man, the people that have signed up to listen today, really good. So we're excited to hear what they have to say. Go
Awesome.
ahead, take it away, Brad.
Well, thank you, Andrea. Thank you, Judy. We'll see you here in just a short while. I do want to start by reminding you at any time, if you have a question as it pertains to what we're talking about here today, please feel free to type it into the chat. And we definitely want to talk about what you want to know about for sure. But today's title, Optimizing Your Wet Sump Oil System for Peak Pressure and Performance. And joining us is Michael Zeranski, the President and Chief Product Specialist for Canton Racing Products. And Mike, welcome. How you doing today?
Good morning. Yeah, thank you, Brad. Yeah, we're excited to be on and hopefully have a really good conversation here and be able to answer some of the questions that we typically get here in the office and, hopefully, make things a little easier for people out there who are trying to figure out how to tune their wet sump systems.
Yeah, and I like that. And more specifically, you're talking about the wet sump system. And look, we know you guys make a wide range of oil products and wet sump, dry sump, all of that. Why today? Why specifically wet sump systems?
Absolutely. We do dry sump, we do wet sump, and but realistically, 98% of the vehicles out there are wet sumps, even when you consider the high performance, the Mustangs, the Camaros, Chargers, even most of the BMW M series, they're going to be wet sump systems. So when you talk about racing, especially racing that is based on a production-based vehicle like SCCA or NASA, you know, majority are going to be people, working with those production-based vehicles, working with wet sump systems, um, local circle track, also very much wet sump systems. Sure, there's some dry sump at the higher levels, but there's a lot of people that are trying to work with those wet sump systems and get them to go. Drag racing, certainly in bracket, comp eliminator, you're going to have a lot of wet sumps. And the reason for that is because the wet sumps do work. It's not always necessary to go with a dry sump system. And we do get questions where people come in and say, well, gosh, I've got this problem or I've got that problem. And a lot of times we're able to work with them, talk about some of the things we're going to talk about today, and they can get that wet sump system to work and perform for their application. So it's not everybody's going to have that NASCAR or that GT World challenge car that's going to have that extra sophistication or even need that extra sophistication of a total dry sump system. And most of the applications that we see is that a wet sump is an effective system. And that's what I hope to show today as we go through. Show all the ways that wet sump can be tuned. It's a tunable part of the car, and you can tune it to where you can get it to work for you.
That's fantastic, and that's what I love about this. Number one, coming up with solutions for racers, but also, like you said, tuning. And anytime I say this all the time, like you can have something that just simply works and checks a lot of boxes without compromise is always a great thing. So, what are some things that racers should be considering when either planning or upgrading their wet sump system?
Absolutely. So just that, at the high level right now, we could say, to stabilize oil pressure is one of the main things people come to us for. And then you want to limit power loss from excessive windage. And a couple things you want to look at. One thing we'll talk about today is just the volume. What is the volume of your oil system? What's the capacity of oil that you have? Then there's pan design. How does your pan design allow for that? What type of baffling is in that pan? Windage trays and features like that to try to, best control that oil. Then oil pumps and the pickups that go with them, that all kind of goes in as well. Clearances between those components, but mostly it's that it's a holistic sort of thing. So we're going to talk about a bunch of different categories, and what you want to do is do the best as you can in each one of those. And you may not be able to check all the boxes, like you say, but if you can address a lot of this, you're going to find that you're going to have a system that can prevent those low oil pressure situations, interrupt or prevent the interruption of critical oiling, and try to prevent any sapping of horsepower. So yeah, those are probably the main things, but we can kind of go through all of them one by one.
Yeah, yeah, sure. Well, then, so where's a good place to start? With all the different things to consider.
Yeah, I would say probably the best place to start is oil capacity. If you look at what is stock for your application, and kind of go from there, kind of how it was originally designed. And if we all think about the small block Chevys and the small block Fords, some of those older engines, typically 5 quarts was the stock capacity in those. But even popular 4-cylinder imports like the Subaru, used in Toyota, GR86, that's a 5.3 quart. Honda K series is 4.4 quarts. So that's the type of oil capacity that you kind of typically see from certainly some of the older models and some of the coming off the production line, generally for street use and so forth. But we understand that if you can increase the capacity, there are some advantages. For us, the first thing we look at is just a bigger pool of oil. The more oil in the system, the more opportunity you're going to have to scavenge that oil, the less chance that oil is going to run scarce. Also, some engines just hold a lot of oil in the top of the engine, up in the heads. Whether it's just because of the way that's built, or certainly overhead cam engines typically will do that. So in those situations, having a little bit more oil to compensate for the oil that finds its way to the top of the engine, when you're at RPM, is important. Another thing, stabilizing oil temperatures. Just a larger amount of oil to absorb and spread that heat out. And even just having that large amount of oil, just you're going to make more contact with your oil pan here. There's more oil touching more parts of the pan. There's more heat dissipation happening with that. And of course, with the larger volume, there's slower heat buildup. You just got more fluid to absorb any heat, which of course in turn preserves viscosity, and kind of maintaining that is important to our oil scavenging and everything else we'll be talking about. But those are probably the big things on volume. The other thing I would say is, so we talked about some of the older small block Fords and Chevys, but if you look at some of the current performance cars, you look at the GM LS, the modular Fords, typically you're going to see them using more oil than their sort of predecessors. In Ford and GM, we can kind of infer through some of their technical service bulletins that they've increased the volumes in some of those things to try to address temperature issues. And if we look at like the GM, the LS in the Camaros, 5 or 6 quart capacities from factory. The C5 Vets, they're about 6.5, 7. Mustangs, the Gen 2 Coyote, they're about 8 quarts. Challengers and Chargers, 7 quarts. So what we're seeing is that, the OEMs recognize you're trying to build these vehicles for track use. You can't go with those 5 quarts that you might have had initially, or that might have come on your crate engine for that matter. That extra oil is the first step. How do you get that extra oil? Of course, you can't just overfill the pan. That there's issues with that. You're gonna get the crank swimming, and that's a bad situation. But if you get a pan that's built right, you can get that extra capacity, and still have all the performance benefits of keeping the oil away from the crank and so forth.
Yeah, and I like that you mentioned not overfilling. I actually saw a video on YouTube a couple of months ago, where this guy he designed like a Lexan oil pan just to show what was happening inside of it, and progressively just kept adding and adding more and more oil, and what it did to horsepower and what it did to all of the other things. So having the right the right pan with the right capacity obviously is critical if you want to be able to use more oil. So how can pan design help in gaining that extra capacity?
Absolutely. And yeah, Brad, it's funny because you mentioned that years ago we had a similar thing. We did some experiments like that where you can see with looking inside the pan and seeing that. And it's kind of back to that idea of the oil volume being a tuning aid in a way. And we talk to racers who will say, can I run it a little bit lower, especially in drag racing, they'll tune it down because the lower they go, the less oil is, the oil's separated a little further from the crank. So it's definitely a range, and you're going to hit that range where you're too high and you're seeing some of those problems like you see in that video. But what we try to do is try to get the best of both worlds. We try to design a pan that allows you to have that capacity without running into those overfill issues. So like pan here, back behind me here, this is sort of what we would call a deep sump. And it is pretty deep at 10 inches deep. That particular pan happens to be for a truck. In an ideal world, that's what you would do. You'd have a huge, really deep pan, and old school drag racing, that's sort of what you had. You had a really old, really deep pan. You got a lot of oil, and it's really far away from the rotating assembly. So you're getting that capacity, and it's not close to anything. But realistically, with modern cars and lowering of the cars, ground clearance doesn't allow for that in most cases, which is why then we typically go with sort of what we call a T sump, a pan that retains a little bit more of a stock depth, but we can accomplish some of the some of the we can get more capacity out of it just by the pan design, by not creating a depth issue. And a lot of it, especially with chassis configurations, limit where we can put the sump and so forth. But T sumps are really popular for chassis cars. Obviously, if you've got a car with either no cross member or a cross member far towards the front, we can do a lot bigger pan because there's a lot more options. So again, it's going to be your particular situation. You want to optimize, get as much oil capacity as you can, be respectful of your ground clearance concerns, be respectful of your chassis concerns. So if that's sort of job one, find that pan that gets you your capacity, but conforms to whatever your ground clearance requirements are, conforms to your chassis. And then the next thing we do, once that's figured out, you look at your baffling system. So we do have a baffling system here. So typically what we do is we do have, like, depending on your situation, we'll do like a road race baffle in this case. So there's 4 trapdoor baffles. You were concerned in road race or drift with motion in every direction. So we built it in that way. And that's what you do. If it's circle track, it's going to be a little different. Circle track, we're going to be offset to one side. If it's drag, we're going to be mostly concerned about acceleration. So that's how we do that. And let's see. Pickups, which are the other part of it, of course, just meant to sort of fit inside and position correctly into that baffling system and make sure you're scavenging from the center of the baffle system. And then, trays that basically enclose the whole thing. So that's kind of what we look to do. And, between the proper pan depth and configuration, proper baffling, we should be able to prevent the windage that occurs, prevent oil running away from the pickup, and go from there. One of the other things we do in the pan is windage trays, which you can see on this pan, we have one in the tray, but then we also do systems that'll install on the mains. So when you do a windage tray, you're really doing two things. You're trying to direct the oil away from the crank and down to the sump where it can be collected by that pickup and baffling system we saw. So you're also, though, trying to prevent the windage that's sort of occurring, that turbulence of oil that's rotating around the crankshaft, that's getting worse and worse every time the pistons move out and air moves between each piston and each cylinder, and as RPM increases. So using either a screen or a louver tray like this is a great way to do that. It's going to kind of reduce or free up horsepower, reduce the parasitic drag, but free up horsepower. And that's what we look to do there. Some people will say, and I'm sure some people in the chat will say, how much horsepower can I look to gain with a windage tray? And there's an answer, but it's a tough one to nail down depending on your application. Now, it depends on the particular of the engine, how much your engine is suffering from windage issues. So, if it's a street car and you're driving around town, you probably don't have a big windage issue. So, putting on a tray is probably not going to change your performance. But if it's a big crank engine, it's going to create a lot of extra windage. Certainly, if you're a stroker, that only adds to that. Okay, so everything's moving around even more so. And then RPMs. So usually we say about 5,000 RPMs is a good mark to say, okay, if you're running 5, now you start to see the benefits of windage tray systems. Certainly above 6,000, you start to see more. And you could get anywhere from 5 to 15 horse on an engine if you put in a tray and above that RPM range, you're going to see all that windage, all that parasitic drag that was occurring can be reduced, and you're going to free up that horsepower. It doesn't create horsepower, but it frees it up. And so 5 to 15 horse, I'll take 5 to 15 horse on race day. So so if you're doing race applications, including a windage tray is critical on the horsepower side, but also even on the oil control side, because again, all that windage, as much as it affects your horsepower, it also kind of interrupts the scavenging of oil that's occurring just below the windage tray. Another question we get, Brad, which one do I choose? I've got a screen tray, I've got a louver tray. So, and that's like the debate as old as time, and some engine builders will have a preference. Here's the way we look at it. The screen tray, and typically when you do a dyno test, the screen tray is going to perform a little better. And that's because it does a really good job of getting the windage off the crank, or getting that oil that's otherwise kind of moving around with the crank, of getting it separated. And it's going to be hard to see on the camera, but these are sort of a one-way screen. It's sort of like a cheese grater, if you will, where it passes through fairly easily in one direction, but not so well in the other. And but yeah, that creates really addresses the windage issue and frees up horsepower. So if you look at the dyno, you say, this is what I like. However, this tray also provides some of that, but what we provide, because it's a solid tray creates a little stronger of a barrier between the oil that's already in the pan and the rotating assembly. So the problem with the dyno is it's stationary. You don't have those dynamic forces of acceleration, of braking, of hard turns, to really see what's happening in the pan and with the oil that's there. So this tray, the solid tray, seems to do a little better job, in our opinion, of preventing the oil from splashing into the crank. So definitely, I recommend, if you are doing any type of aggressive road racing, it's certainly off-road, type of things where you're really getting some pretty violent action. A louver tray, even though, if you dynoed it, you might be a percentage or two different, but in reality, the louver tray is gonna be your best solution in that situation.
I like that. That's really neat. Mike, we have a question from the chat, and it kind of goes back to what we were talking a little bit earlier. How do you determine that you have a lot of oil in the upper part of the engine, and then determine how much you can overfill to compensate? And I'm assuming overfill is maybe talking about a higher capacity pan as opposed to overfilling the stock pan or something you have in there.
Yeah, and that's a tough one. I don't know if there's a way that you can measure it. It's pretty hard to check a dipstick when the engine's running, just because it never comes out clean. But you know, you kind of know it based upon the engine, basically, based upon your build. Um, when the engine builder built the engine, or you built the engine, did you do different things to, perhaps, put some restrictors in, or is it an overhead cam engine? You're going to expect it more there. So you can kind of look, there are certain factors, just the way the engine's built, that'll give you an indication whether your engine falls into a category that's going to pull a lot of oil, or not. Um, you know, if you could find a tricky way to measure it, that would be pretty good. But I'm not sure how to measure it when it's running, which is what you need the snapshot for. But generally, just going on engine, layout, and knowing whether your engine is the type of engine that's gonna do that.
Well, and how does that tie in now when we start talking about an oil pump and pickup combination?
Yeah. So, because exactly. So, we've got oil in the pan. It's fairly well controlled, but that's only half the battle, obviously. So we've got to get that oil delivered into the engine, and certainly things can fall apart at this stage if it's not, everything's not tuned up. So oil pumps. Now, we're not an oil pump manufacturer, but we obviously look a lot about pumps, and we build pickups to match to the pumps in our pans. And it is a big part of designing that wet sump system. So of course, there's high volume pumps, standard volume pumps, high pressure pumps, a lot of aftermarket options for you. And again, it's going to kind of depend on the characteristics of your engine build. Um, Larger bearing clearances, things like piston squirters or valve oilers, they're going to require more volume. So generally, you're going to look at more of higher volume pump options when you're approaching it from that point. Oil viscosity can play a factor. We've talked to a lot of customers. It says, "Hey, this thing's working great. Last season, this place I have a problem," and it could just be you switch your oil brand, or you try to go with a different viscosity, and that can have effects. Obviously, thinner oil, it's going to be easier to flow, but it's going to be a little harder to build pressure. So that's something to concern, to look at, and that may affect your pump choice. So that's important. High volume versus high volume or standard volume, and then pressure considerations. How much pressure are you trying to achieve? We all know there's issues with low pressure. We all fight low pressure. Um, you don't want to go below a certain level to you start to lose that hydrodynamic lubrication that just keeps the metal surfaces from making that metal on metal contact. So you need a minimum level of oil pressure, but on the same time, if you're doing a race application and horsepower, if you want to optimize horsepower, we all know that creating a lot more pressure than you need is wasted energy. It takes quite a bit, for that engine to turn that oil pump. And if you're the oil pumps have a bypass. So if you're turning it just to bypass it, it's wasted energy. There's also concern, and especially some of the older gear style pumps of just sort of not a smoothness, a little bit of pulsation that's in there. And again, there are aftermarket companies. I think of the Melling Shark Tooth pump that's there just to try to eliminate that pulsation. So that's a concern when you're looking at pressure. Um, Sometimes oil coolers and accessories will play into it. Typically, if it's just a couple feet of line in a cooler, not too bad. But in these occasions where you've got lines running from the front of the car to the back of the car and then back forward again, it can start to play a factor. And you might have to say, okay, what sort of flow do I have to create to get the pressure that I want at the engine? Um, you know, but again, those are things you consider when you're building the engine, and probably look to some oil pump manufacturers to fine tune that choice. But once you make that choice, on our side, it's going to be what pickup do you choose to go forward.
Yeah,
Yeah.
and you have a lot of pickups to choose from for a given block and pump. So how do you choose the right one?
Yeah, so a couple more samples here. Pickups, they come in, they're all a little bit different. We look back at some of so this would be a small block Chevy pickup, and this is sort of the standard, 5/8 tube. And again, back to that volume thing, most of these will offer two different size, a 3/4 tube, and that's based again on that pump that you choose. A lot of pumps they probably have an option where it's going to be a slightly larger diameter. The suction side of the oil system is going to be, limited in what it can produce. You can only suck as much as the atmospheric pressure and friction and viscosity effects played into it. But you have a finite amount that you can bring through this tube, and and that's where you do see cavitation issues in pumps and in pickup tubes when you're trying to bring more volume through a small tube like this than you're capable of. So one of the things to consider is the larger tube diameters. And that'll be often something that when you're dealing with higher RPM ranges, you've got that higher volume pump, high RPM, you want to consider that slightly larger tube. Sort of more examples here. We got some examples. Same thing on, this would be a small block Ford pickup. And again, it comes in your sort of standard 3/4, and then our larger 7/8 design. So again, for most of these, you're going to choose the pickup to match up with the pump. Sometimes that means a larger diameter. And just speaking about diameter, it's crazy, Brad, because we go back and we look at some of these tubes here. And if you look at like the modular engines, the LS and the Ford modulars, and now the Coyote, the tubes have gotten so large, and that's this is out of the this is our pickup for the like a Coyote 5.2, like a GT 500 type of setup, and the diameter is up to 1.125 inches, and this just goes to show that the OEMs recognize, and as you're building the engine, you'll have to recognize that you are limited in suction. So as that RPM increases, as the volume increases, you're gonna have to look at larger diameter tubing. But again, that's not mean to say you're going to put a 1-inch diameter tube on your small block Chevy. That just means to say that you may consider one of the slightly incremental larger pickups for your application. They're out there. The good news is if you go to buy a pump and you go to buy a pan, you don't have to invent anything. It's there as long as you're aware of it. And when you're shopping, you see that there. Yeah, as far as which pickup you choose for the pan, so we do make pickups specific for each type of pan we make. Some pans will have several different type of pickups that are offered, again, to go with what pump choice you made. But even within that pan, again, that pickup is, as I showed you before with the baffling, it's set to sit in a very particular spot. in the baffling, in the pan for the maximum amount of scavenging. It's also adjusted for height because, of course, if we go to one of these deeper pans over here, but we're using that stock pickup, we're not sucking at the bottom of the sump, and you're not really taking advantage of all that oil that sits below that stock depth. So every pickup has to be adjusted for the pan it's fitting in. Try to get about 3/8 clearance between the bottom of the pan and the pickup, and which can be adjusted with depending on your gasket choice. It all plays in. And usually we all set them up. If you buy the right pickup and pump combination, it should all line up. But also, it's just good to be aware that when you are setting it up, you do want to check that. Some guys will use essentially some clay to form in between the pickup top and the pan. So when they do their test fit, they can remove that, look at the clay, get an impression of what their clearance is, and then move from there. And again, we look for about 3/8 is a good comfort zone where it's low enough to get all that oil at the bottom, but not so low that that you're going to be a risk of not getting enough flow through there.
Hmm. I like that. What about accessories to the oil system? I mean, you've already mentioned a couple of things, and obviously like oil coolers and a bunch of different things. How can they hurt or help?
Yeah, accessories, coolers, heat exchangers are some of the things that come to mind. So obviously they're going to correct temperature issues, which I think we've talked about temperature when we talked about the volume of your system. And as much as we're talking about oil control with the pan, temperature is often part of that equation. Temperature issues can cause oil control issues. Because it's a viscosity breakdown. Sometimes you don't see foaming too much anymore, but it could happen. Issues like that come up. So if we can control the temperature, that's definitely a big part of getting a good solution. Um, Also sometimes high temperature is an indication of, a sort of an ill functioning oil control. So if the more that windage that's splashing up from the crankshaft into the back of the cylinders, it's absorbing heat. It's getting hot. If you do get any aeration in the oil because that oil is getting whipped up by the crank, that aeration only exacerbates the issue, and eventually causes oil scavenge issues. So controlling the temperature definitely is part of it. Coolers, heat exchangers, be mindful of that. We always ask people on the phone, what's your temperature when we're talking about issues they might be having with oil issues. And then beyond that, the other big accessory that we like to talk about, especially when you've tried to check a lot of the boxes with the oil pan, or maybe your application just is a unique one where there's just not an oil pan available. What we like to do is we talk about our AccuSump unit, which is an oil accumulator. And this is a great way to provide that extra level of protection, either or just add it on top of your oil pan solution to get a little extra. You get a little extra capacity because you'll have additional oil stored in the AccuSump. And you also get a little extra protection because that oil will be there to basically surge back into the system. We get a lot of questions on this, so I'm going to go through it. They want to know what's inside. So inside, this is a clear one, and there's a piston inside, and that's sort of how it functions. And you can see this one is much larger than what we have here. We do have several different sizes, but basically, one side is going to fill up with your oil pressure. One side of it is going to be air pressure that's basically going to act as a spring and become sort of charged from your engine and discharged when you need it. And actually, Brad, I do have a let's see, a screen share that might even help with this.
Please. Yeah, this is a really neat system.
Let's see here.
All right, we can see that.
You got it? Okay, great.
Yeah.
So yeah, so basically what you can see here in the green, we're looking at the AccuSump system charging. So, under normal conditions, pressure is good. Um, Oil is flowing to the AccuSump. Most of the oil is going to the engine, but a small amount of oil is pushing against that pressurized piston. And that AccuSump is filling up to the same pressure level that your engine's performing at. Then you could see in the red diagram that if there's an interruption in the engine oil flow for whatever reason, that AccuSump will discharge to the engine. And it does that simply just because of physics. It does that because the only thing holding the oil in the AccuSump under that circumstance is the pressure that the engine's provided. The engine's pressure is sort of is the plug that's holding the oil in the AccuSump. So as soon as there's a little bit of an interruption in that engine pressure, we see the oil in the AccuSump wants to naturally come out and come back into the system. And I also have we do have a little performance data on this that one of our customers was lucky, we were lucky enough to have them share with us. And so this first diagram I'm showing you is without an AccuSump. So this is what their data looked like before an AccuSump was introduced. And I'll explain the graph a little bit here on the left side of the screen. We have our oil pressure. We have RPM across the bottom, and the colors sort of represent oil temperature. So you can see, so at lower RPM, especially when cold, pressure is good, and as RPM increases, we expect, pressure moves up. But what we do see too is you see this whole area here where around 5,000, 6,000, certainly up to 7,000 RPM, we're getting this sort of all these data points of oil pressure that are between 10 and 20, which most people agree that, once you're below 20, you start to get a little nervous, especially when you're spinning 5,000 RPM, 6,000 RPM and above. So that could be a concern. So this customer, they saw that, they knew it was a problem. And, it may not blow your engine up right then and there, but what it does is all those momentary interruptions in the oil flow start to create a little wear, start to create some hot spots, and it will cause longevity issues. So what we see in the bottom graph here is after the AccuSump was introduced. So after the AccuSump was introduced, we still have very much the same sort of profile where our pressure's increasing with the RPM, and certainly we see the oil temperature increasing. But what we don't see are all those sort of rogue data points that where you're at high RPM and you're hitting 10, 15, 20 psi. So they've been able to creep, stay across the RPM range. This is presumably across more of the aggressive portions of the track, and maintain pressure at an acceptable level with the introduction of the AccuSump. And so that kind of pretty much shows what it can do and how simple it is. And in an ideal world, we look for people to have a really great pan. And sometimes that's enough. Many times it is. But if they can't do a pan or they can't get that pan sorted, we will often talk about the AccuSump, or it's just a great addition. But I'll stop the share there. I'll come back to you now. But yeah, so that's I think that's for us, those are the main things to look at with your wet sump system. Volume, baffling, windage, your oil pump and pickup selection, and then accessories like coolers and AccuSumps and how that can play into your overall performance.
That is really cool. We have a couple of questions from the chat. I know we're getting a little bit short on time, so we'll see if we can get to as many here. It says, my application is a BMW N54 twin turbocharged inline six. This engine uses an electronic dipstick with nonlinear display logic. It shows full as low as 1 quart low and only reports when a full quart needs to be added. Oil must be full to half a quart overfull to avoid serious low oil pressure transients on the track. The only way to actually know the oil volume is to read the sensor live data with a code reader, which many people don't know. The engine is inclined 30 degrees from vertical, which makes left-hand turns particularly critical. Live data, hang on, I'm trying to scroll. Okay. Live data fluctuates wildly on track and is not really useful, but experience shows the engine must be full to slightly overfull to survive, and that has to be measured under steady state warmed up running conditions. Presumably, the fundamental problem is both sloshing and slow return from the head.
Mm.
Um, so is that something that now we can talk about baffles, a higher capacity, and different things like that to help cure?
Yeah, yeah, I could see that, and I'm sure the OEM was, recognizing again that the oil is going to be up in the heads, and they don't want, 1 quart load to cause alarms, for the user, especially the street user. But yeah, realistically, when you're on track, you got to be aware of, yeah, that could be an issue, and a lot of people figured out the way this individual did, where you kind of experimentation and you find out with the data. But I would say, yeah, baffling is going to help that. And if you can get that extra capacity, because again, if you can get that extra capacity without raising the height of the oil, then that's all free. That's not going to affect those performance issues, those overfilling issues. So, if you are in an opportunity where you can expand the pan to hold a little bit more volume, now you can essentially overfill it so that when all that oil does end up in the top of the engine, you're still at a really good level down below. That would be great. And then baffling, obviously, to keep that oil there. I would also say, because I don't, that BMW, the inline six there, I'm not sure what the oil pan options are and what you can do. But that's often where we talk to people about AccuSumps again, where the AccuSump sometimes is another way people think of it, is especially with one of those larger ones, that's extra oil. So when you add an AccuSump unit to your engine, um, you're going to have to put more oil into the engine to compensate for the oil that's sitting inside the AccuSump. Especially with our larger units, or 2 quarts or 3 quart units, you may not add 3 quarts for a 3 quart, but you probably might add about two, to adjust for the fact that there's always some in the AccuSump. So that's kind of a clever way, or a roundabout way, of adding oil volume to your system, um, without having to, worry about that volume sitting in the bottom of the pan. But it's still there. It's still being delivered as, as part of the overall volume of the system. So I might suggest that, yeah, some extra volume if you can get it, either through a pan or through an AccuSump.
I like that. Another question: do you recommend crank scrapers and perhaps include them in your windage trays or oil pans?
Yeah, yeah, that's great question. Crank scrapers are definitely part of that, windage control sort of package. Whether it's a crank scraper that's built into the side of the pan, and a pan like this does have a little bit of a crank scraper that we do typically put one in here. Um, some of them are bigger. We offer, some larger ones. Sometimes the windage tray almost acts as a de facto crank scraper. For drag applications, we do what we call an oil recovery pouch, or sort of nicknamed a power pouch, because it creates a little extra power. And that's sort of a crank scraper that not only is it grabbing that oil that's coming off the crank, but it's creating like a pocket for that oil to find itself in, and then drain back down far away from the effects of the windage, far away from the effects of the crankshaft and all the turbulence that's around that. So crank scraper is definitely, when you're looking to try to maximize horsepower, crank scraper windage tray combo. If it's total horsepower, then a power pouch as well, to try to do the best you possibly can to use all those features, kind of all the tools in the toolbox, if you will, to reduce that windage, free up, that horsepower that's, being absorbed otherwise.
I like that. And one final one here. You mentioned oil aeration. Have you found any difference between the two windage screens that you've shown with regards to oil aeration?
That's a good question too. I wouldn't say we have too much. Usually excessive aeration is usually a sign of a little overfilling the sump where it's just, getting in there a little bit too much. I think they both do a pretty good job from that point of view. Again, it goes back to the screen is going to do a better job of letting that oil off the crank. But if you do have an application where there is a lot of vehicle movement, and let's face it, if you're racing, I don't know too many that don't have that, unless it's just pure, dyno pulls or something. But, if you're racing in any capacity, you've got G-forces in one direction or another. And, that's where that louver tray is going to do a little better job of preventing that. Sometimes we ask people too, does the problem start off like right off the bat, or is it after several laps? And that gives us an indication of, if it's something, if it's something that doesn't appear until several laps later, then it usually means it's this slow increase of, aeration building up, because, that doesn't happen like instantly, right? When your first lap, that's the type of thing that's going to happen as you go. So if you're getting it from that, I say a nice, if you don't already, I would invest in a really good windage tray to create that barrier. Make sure that either the oil in your sump isn't making its way up into the crank when it shouldn't be, and oil's draining back appropriately.
That's awesome. Mike, this has been just one heck of an education, and really cool to see the great products that Canton Racing Products has to offer. The AccuSump is just awesome. Just what a great idea of engineering.
No, I appreciate you saying that. Thank you. It's been good to come and talk to everybody today, and it's happy to have the opportunity.
Thank you, Mike. We appreciated that. And I love the interaction from attendees. Love the questions. So thank you.
Mm-hmm.
Thank you for joining us today. Next week, we are going to be talking machines, and we will have MEC CNC machines on. So please join us, and thank you for joining us.
Thank you, Mike. Thanks, Brad.
Hey, we want to thank you for watching. Now, be sure to like, subscribe, and click on the bell so you're always up to date with the latest racing technology, industry insights, and exclusive content from ePartrade.
ePartrade is a digital platform that we've created basically to make life easier in the business community of auto racing.
ePartrade, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier.
When you see a product that you're interested in, all you need to do is click on request more information, and then from there it is forwarded directly to the buyer or to the supplier.
ePartrade really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Land speed record holder George Poteet's Speed Demon rocketed 481 miles per hour at the Bonneville Salt Flats. You don't go that fast without ARP fasteners.
There is no way that we could go the speed that we've gone, the number of times we've gone, with a lesser quality bolt than ARP supplies to us. And we absolutely wouldn't be where we were today if it weren't for ARP.
When failure is not an option, it's ARP-bolts.com.
We're Performance Plus Global Logistics. Our team of dedicated performance industry and logistics experts get valuable cars and components to the track on time in top condition. We provide expedited logistics solutions for the performance industry using direct routes instead of deferred options, and communicate all necessary information to the appropriate resources to meet regulations and ensure a smooth transit and secure delivery, both domestically and internationally. And we exceed customer expectations by providing best-in-class service with an efficient and cost-effective system in place. Contact us today to book your next shipment.
You work as hard as your truck, and you have no time for downtime. That's why more truck owners trust Blue Def, America's #1 diesel exhaust fluid brand. Each batch is guaranteed pure, so you can avoid costly repairs caused by inferior DEF. Demand America's best for your truck. Blue Def at Blue Def Platinum. Put trust in your truck.
With roots in the Midwest that date back well before the Model T, Fifth Third Bank has a long history of serving the needs of automotive companies. While much has changed over the years, our passion for helping businesses put cars on the road and on the track has not. Today, we are more committed than ever as a member of SEMA, a founding member of PRI, and a sponsor of multiple race teams across several racing series. Where can we take your business? Fifth Third Bank.
Where will you find Farea Racing components? Circle track, drag racing, and any top race shop. In every form of motorsports competition, our valves and valve train components deliver race-proven design and technology. And we've brought that same performance to our street applications as well. We're backed by 5 decades of experience, an extensive range of off-the-shelf components, and our custom valve department has the fastest turnaround times in the industry. Farea Racing Components. Stand with us or race against us.
When it comes to pushing the limits of performance, the pros know there's no room for compromise. At Crower Cams, we don't just engineer camshafts and valve train components, we redefine what power means. Since 1955, Crower Cams has been the name trusted by racers, engine builders, and gearheads around the globe. Whether you're building a street machine, a dragster, or a track car, Crower Cams provides the muscle you need to dominate. And with Crower, victory is within your reach.
At SeaTech, we're on a mission to lead the storage industry through innovative custom-built solutions that meet every challenge head-on. Designed for versatility, whether in a commercial setting or at home, we create high-quality, durable products that stand the test of time. SeaTech, engineering and innovation.